It's like the digits, and I like doing the words, but it's the digit ones that get me a bit confused.
I get you. So let's use this one as like a specimen, and then we're gonna break it down nice and slow, especially for this 5-mark question. So the idea is, if they ask us something like this, it says the digits 1 to 7 are used to create a 4-digit code to enter a locked room. How many different codes are possible if the digits may not be repeated and the code must be an even number bigger than 5,000? So you see, we've just read the question. That's not good enough. We've just read the question, it's okay, but we now have to read it again while laying out the structure that's going to help us answer this question. I'll repeat. When we're reading it again, we lay out a structure that's going to help us answer the question. So a structure that's going to help you answer the question is basically linked towards what they're asking. So they're talking about us using digits 1 to 7. So you want to visually see what that looks like. There's 1, 2, 3, 4, 5, 6, 7. There's 7 numbers that we're using. They are used to create a 4-digit code. So what you do is you want to see that there's going to be a slot for this thing here, second position, third position, fourth position. So this is what our code is going to be looking like. And then they say here, how many different codes are possible if the digits may not be repeated? So you have to highlight certain things that are restrictions. So digits may not be repeated, that's one thing. And then they say here, and the code must be an even number. So 2 things, no repeating, and it must be even. You see?
Yeah.
So what you do is, you see here, we technically have 4 limitations. The first limitation is the values that we can use. The second one is we cannot repeat those values. The third thing is the code must be an even number. Actually, no, this is the third one and the fourth restriction. The second restriction was the fact that it has to be a 4-digit code. You see, that's the second restriction. The third restriction, digits may not repeat. The fourth restriction, it must be an even number. So what you do is you need to satisfy each of these restrictions one by one. So us knowing we have to choose numbers from 1 to 7, that's simple. Us knowing that our digit has to be our code has to be 4 digits, that's also simple. That's why we only put 4 slots. So we have satisfied this. This is easy to satisfy. This is already satisfied by default because we're only visually seeing 4 slots. Now, if they say that the codes are, they said here we need to, how many codes are possible if you cannot repeat and your code must be an even number that is bigger than 5,000. So we actually have 5 restrictions. The number has to be bigger than 5,000. So it being even is not good enough. It has to be even and it must be bigger than 5,000. So what you do is you want to satisfy the restrictions that are the most stringent, the most strict ones. Like for example, the it being 4 digits, that's the most strict one. So you already are only seeing 4 places. Secondly, the fact that it has to be bigger than 5,000. Do you see that it limits the numbers you can put in front here?
Yes.
Yeah, it means we cannot put a 1, we cannot put a 2, you cannot put a 3, you cannot put a 4, you cannot put a 5, you cannot put a 6 or a 7. So in a situation like that, right, where you cannot put 1, 2, 3, or 4, you can only put a 5, 6, or a 7. So what you do for yourself is when you work out questions like this, you almost need to put yourself in the situation where you will be saying to yourself, okay, fine, I need to make a decision as to how many options can go in here. That's how these kinds of questions work. You work in terms of how many options can you place in a certain position. So you say to yourself, how many numbers can potentially be in here? It cannot be 1, 2, 3, or 4. The numbers that can potentially be here, it's only 5, 6, and 7. Do you agree?
Yes.
Yeah, because the number has to be bigger than 5,000. So since it can only be 5, 6, or 7, It means that here you only have 3 options. You get it? There's only 3 options for that place in the beginning.
Yeah.
You
So
get it? Yeah.
basically, I'm not putting in numbers, but I'm counting the amount of numbers that can go in there.
Yes. Yes.
Okay. Makes
Yeah.
sense.
So that deals with this factor here. Now, the other thing is, if your number is going to be an even number, it has something to do with what goes at the end here. Do you agree?
Yes.
Yes. So if your number is going to be an even number, you see that there are only what you call 1, 2, 3 options for the back here.
Yes.
Yes, you know that there are 3 options for the back.
Yeah, because it's
But
going to
then
be an even number as well.
yeah, but then now when you get to this point, you start to wonder and you're like, but wait, what about scenarios where the beginning is a 6 or something like that? Because if the beginning is a 6, it means that the end can also not be a 6. So we would not necessarily have 3 options for the front and 3 options for the back. So in a situation like this, you're seeing that the question is just becoming a bit difficult for you to like work out just by using an image like this. So in a situation like that, what you have to do is you have to think to yourself, okay, fine. The front here only has 3 options. So you might as well lay out the 3 different kinds of numbers you can have. You can either have numbers that start with a 5, and then you have numbers that start with a 6. Lastly, you have numbers that start with a 7. This is how you can now look at it. To say that, okay, fine, instead of just looking at it in terms of one picture that you're going to use to help you answer your question, you can look at it as 3 pictures. To say, let me count how many options we have for numbers that start with a 5. And then you count how many options we have for numbers that start with a 6. And then you count how many options we have for numbers that start with a 7. Do you see that?
Yes.
Yeah, and us making this decision, it's because of the fact that our restrictions are a bit many. So for us to go around the fact that a number cannot be repeated and our number has to be even, it looks like it's best for us to see that, okay, let's work out the total number of options we have for numbers that start with a 5, starting with a 6, starting with a 7. So let's deal with the one starting with a 5. So the number starting with a 5, you know that in the beginning here, there's only one option. You can only put one number in there, which is the 5 that we're talking about.
Yeah.
Secondly, we need to now think to ourselves, okay, fine, this number has to be an even number. So logically speaking, if it starts with a 5, in the back here, we have 1, 2, 3 options. You see, we can either put a 2, a 4, or a 6, so we're safe. And then now you ask yourself, okay, fine, once you put a number in the front here, and once you put a number at the back here, you have used up 2 numbers out of the 7. Do you agree?
Yes.
Yeah. So if 2 numbers out of the 7 are used up, it now means that for this position here, you only have 5 options. And then once you put a number in here, you only have 4 options for this one. See, that's how you work out your total number of options for a specific slot in your question. You don't necessarily have to look at it from left going straight to the back. You have to satisfy your restrictions first. So the first restriction was it has to be 4 digits, so we put 4 positions. And then secondly, we want to think of numbers that are bigger than 5,000. So we're starting with ones that start with a 5. So we put a rule to say there's only one option for the front here. And then the back, if you're gonna start with a 5, you can still end up with a 2, a 4, or a 6. So we have 3 options in the back.
Yeah.
And then the logic behind that, we said, okay, fine, once you put a number in the front, and once you put a number at the back, you only have 5 options left for this position here. And then you have, once you put a number here, you only have 4 options here. You get it?
Yes, I get it.
Yeah. So it means that for numbers that start with a 5, these are your total outcomes if you multiply these numbers. So you do the same for the 6 and the 7. Now, when you will do the same for the 6, you ask yourself, okay, we want to find out how many numbers start with the 6, right? So us finding out the numbers that start with, let's see here, us finding out the numbers that start with, let's see, let me see here, let me see here, let me see here, yeah. So us thinking of numbers that start with a 6, right? We need to ask ourselves, there's only one value. In the beginning, there's only one option. Once you put a number 6 in front, for the back here, you only have 2 and 4 as options.
Yes,
you see that?
because you've
Yeah.
used 6 already.
Yeah, yes, because numbers cannot be repeated. We have to work simultaneously. We have to satisfy all the restrictions, you see. So the next thing now is we're gonna say to ourselves, okay, fine, once you put a number in front here, once you put a number in the back here, you only have 5 options for this position, right?
Yeah.
You agree?
Yes.
Yeah. And then once you put a number here, you only have 4 options for this one. You agree, right?
Yes.
Yeah. So with all that being said, you can now just think to yourself, okay, fine. The number of options here is just 1 times 5 times 4 times 2. And then you move on to the 7. You do the same thing. Numbers that start with the 7, there's only one option in the front. Once you put a 7 in the front, for the back, you still have 3 options because you have 2, 4, 6. Once you put a number here and here you only have 5 options now, and here you only have 4 options. So now you add up these totals here. So all these, the number of options for the 5, the number of options for the 6, the number of options for the 7. This is like 20 times 3, which is a 60.
Yes. Next
I mean,
one's
this is also
40. Yeah, 60 and then 40.
So it's going to be 60 plus 40 plus 60, 140 codes.
Isn't it 160?
Oh yes, 160. Thank you. Mental math is dangerous. Yes, it's 160. Definitely 160. Cannot be 140 in any world. So that's how you work out this kind of a question. So the way you can see the way we did it. We didn't just do from the beginning to the end just one way. What we were doing in the beginning, that normally works if you have less restrictions. But the more restrictions you have, the more your question needs to evolve when you're answering it. Or rather, the way you need to align your answer properly. You have to accommodate the different restrictions. So here, if it's a matter of us seeing, okay, let's build ones that work with that start with the 5, and then we dealt with ones that start with the 6, and then we dealt with ones that start with the 7. If we were able to just do that individually, that's 100% okay.
Yeah.
So let's move on here.
Yeah.
And then it says here, let's hear you. You're going to say?
No, I'm saying that makes sense. So gotta take it like break up your question one like piece by piece to do it.
Okay, yeah, no, I hear you. I hear you. I hear you. Yeah, so the idea now is with the next one, it is asking us, oh, there is no next one for this probability question. Oh, that's kind of awkward. But I guess that's okay.